So in the previous examples, we have looked at how we do a lower tail test and an upper tail test using both the critical value approach and the p-value approach. So now let's do a two-tail test, and let's still assume that we know the population standard deviation. So we assume that we know sigma. So let's say that Starbucks claims that the average wait time at East UWG, the UWG store, is 10 minutes with the standard deviation of 3 minutes. A survey of 40 customers use a mean of 11 minutes. The question is, do we have enough evidence to say that the average wait time is not 10 minutes? And let's consider the 1%, 5%, and 10% level of significance. Okay. So now, by now, hopefully, we're familiar with the first two steps of a hypothesis test, right? So first up, we want to develop the null and the alternative hypotheses. Okay. So here the parameter of interest is the population mean, right? Because the keyword is average. Okay. So we're testing the company's claim. So the company's claim is going to go into the null. And the company claims that the average wait time is 10 minutes. So mu is equal to 10. And we want to show that it's not 10 minutes, right? And so the alternative is going to be mu is not equal to 10. Okay. So now looking at these hypotheses, we can tell that this is a two-tail test. Now we also know that we have a sample of 40 people, so n is equal to 40. Right. The sample mean is 11. The population standard deviation is given, which is 3. And then the hypothesized value is 10, right? Again, it's whatever shows up in the hypotheses. Step 2, you want to calculate the test statistic. Again, we know the population standard deviation, so the test statistic we use is going to be z equals x bar minus mu sub 0 divided by sigma x over the square root of n, right? Which is 11 minus 10 divided by 3 over the square root of 40. you do the math here, you get 2.11 for your test statistic. Now let's proceed with the p-value approach. First off, we want to formulate our decision rules. Recall that alpha is equal to 0.01, 0.05, and 0.1. So the decision rule is we reject the null if the p-value is less than alpha. Lastly, let's try to reach our conclusion. Right. In order to do that, we need to calculate the p-value, the value of the p-value. So let's draw the standard normal distribution. And the reason we're using the standard normal distribution is because we know the population standard deviation, right? So we're using the z-table. Our test statistic is .11, right? So if you recall from a video earlier, when we have a two-tailed test, the first thing you want to do is you want to identify the negative of the test statistic. So in this case, you want to identify negative 2.11. The p-value in this case would be, so the p-value is going to be the sum of the shaded areas. In other words, it's the sum of the probability that z is less than or equal to negative 2.11 plus the probability that z is greater than or equal to 2.11. The first term is fine. We just want to keep it as is. The second term, we want to flip the inequality in order to use the table. So this is going to be 1 minus the probability that z is less than or equal to 2.11. Okay. So now we can go to the table. For the first term, you want to go to the table, look at row negative 2.1, and then look under column 0.01. Right. That gives us a probability of 0.0174. Okay. Now, for the probability that z is less than or equal to 2.11, you want to go into the z-table, look at row 2.1, look under column 0.01, and that gives you 0.9826. So if you do the math here, the p-value is going to be equal to 0.0348. So now we're ready to reach our conclusions. Okay. Again, we're testing at the 1%, 5%, and 10%. Alpha is therefore, as we have mentioned, 0.01, 0.05, and then 0.1. The p-value is the value we just calculated. So the p-value is 0.0348. So now let's conclude. Okay. At the 1% level of significance, the p-value is 0.03. The value of alpha is 0.01. Right. So our conclusion is that we do not reject the null. Okay. And this is because p-value is greater than alpha. Now at the 5% level of significance, our p-value is 0.03, alpha is 0.05, so obviously the p-value is less than alpha. So based on our decision rule, our conclusion is that we reject the null at 5% level of significance. This is because the p-value is less than alpha. And at 10% level of significance, the p-value is 0.03, alpha is 0.1, so again we reject the null. Okay. Because p-value is less than alpha. Okay. So we're done with the p-value approach. Let's now look at how we conducted the test using the critical value approach. Okay. So what is our decision rule? Remember that this is a two-tailed test, right? So we reject the null right, if either of the following statements is true. Right? If the test statistic is greater than the positive critical value, or right, the test statistic is less than the negative critical value, where the critical values are plus minus z sub alpha over 2. Okay. Okay, that was step 3, right? I forgot to write it here, but that was step 3. Now let's try the draw conclusions. Okay. When alpha is equal to 0.01, then the critical values are plus minus z sub alpha over 2, which is plus minus z sub 0.005, which is plus minus 2.58. Right. When alpha is 0.05, the critical values are plus minus z sub alpha over 2, which is plus minus z sub 0.025, which is plus minus 1.96. And then when alpha is 0.1, the critical values are plus minus z sub alpha over 2, which is plus minus z sub 0.05, which is plus minus 1.645. Right. Now recall that all these values have been given to you in one of the previous videos, right? And I am able to use these values because these values are applicable because sigma x is known, which allows us to use the z table. Okay, so now let's go ahead and draw conclusions from this. So we test at 1%, 5%, and then 10%. Right. Remember that our test statistic is 2.11. Right. Now the critical values are listed up here, right? So at 1% level of significance, the critical values are plus minus 2.58. At 5% level of significance, the critical values are plus minus 1.96. And then at 10% level of significance, the critical values are plus minus 1.645. Okay. So now what are the conclusions? At 1% level of significance, if this is negative 2.58 and this is 2.58, right, then our test statistic is in the middle somewhere. Right? That means that the decision rule from up here, right, is not met. And so the conclusion is that we do not reject the null. Right? Okay. At 5% level of significance, we have 1.96, and negative 1.96. So if this is negative 1.96 and if this is 1.96, where does 2.11 fall? 2.11 fall outside of that interval, right? Which means that 2.11 is greater than the positive critical value according to our decision rule. That means that we can reject the null, right? Okay. And then at 10% level of significance, we have negative 1.645, and then we have 1.645, 2.11 falls to the right of 1.645. That means that the test statistic is greater than the positive critical value, and so we also reject the null. Again, here we do not reject at 1%, but we reject at 5 and at 10% level of significance. You go back to our conclusions. When we use a p-value approach, we did not reject at 1%, but we rejected at 5 and 10% level of significance. So the conclusions were the same regardless of which approach you decide to use.